Hello, my fabulous algebra students. Today we are going to talk about solving absolute value inequalities. So what is an absolute value? The absolute value is the distance from 0 on a number line. Since the distance is always positive, the absolute value of a number is always positive. Okay, so I always use the example in class. If I'm driving from Crum to Denton, let's say it's 10 miles, okay? But if I drive from Denton to Crum, do I travel a negative 10 miles? No, I travel a positive 10 miles. So distance is always, always, always positive, okay? As we go through this video, there are going to be several times that I have a piece of paper where I need you to copy down quite a bit of notes. What I would like you to do is I would like you to pause the video when I say go ahead and pause the video now. Write down all your notes, and then when you turn it back on, unpause it, then we will continue on with the video, okay? So here we go. So let's look at examples. The absolute value. Absolute value are the bars, and I believe that you saw these in 6th grade. When you see the absolute value bars, whatever is inside those bars will become positive, okay? So the absolute value of negative 4 is 4. The absolute value of 4 is 4. The absolute value of 0 is 0. Because 0 is a neutral number. It is neither positive nor negative. All right. So let's go with some expressions. Okay. How do we solve an absolute value expression? Well, we're going to find the absolute value and then we're going to solve. Okay. So, number 1, or A, the absolute value of negative 10 plus the absolute value of negative 10. Now, this is an easy one. So, the absolute value of negative 10 is 10, and the absolute value of the other negative 10 is 10. So, you have 10 plus 10, which is 20. All right? Then over here, B. The absolute value of negative 6 times the absolute value of 12. Now, I do encourage you to make your absolute value bars bigger than your number so that, like, this number doesn't look like 1,121. You have to make sure your absolute value bars are a little bit bigger than your number. So the absolute value of negative 6 is 6, and the absolute value of 12 is 12. All right, so 6 times 12 is 72. All right, let's go one more time. For C, we have a negative on the outside. So we have like a negative 1 hanging out there times the absolute value of negative 5 minus the absolute value of 9. So what do? Well, we're going to bring down this, whoopsie, you already saw the answer. We're going to bring down this negative sign here because you can't do anything with it yet. Okay, so we brought those down. The absolute value of negative 5 is 5. I bring down my minus, and the absolute value of 9 is 9. Okay, so now we have negative 9, or negative 5 minus 9, which is negative 14. So those are pretty simple. Those are things that you did in 6th grade. All right. This is that time that I would like you to take a moment, pause the video, and start writing down your notes. All right. Now that you're back, absolute value equations. A, B, and C are all real numbers, and X is a variable. Now, that is just for this example, sorry. So the absolute value of AX plus B equals C. So A, B, and C are numbers. X is my actual variable in this equation, all right? What steps are we going to take? We're going to isolate the absolute value expression. Step 2, we will rewrite the equation and get rid of the absolute value signs by setting the expression inside the absolute value equal to the positive and negative value of C. Okay, I'm going to reread that. We're going to rewrite the equation and get rid of the absolute value signs. We're going to get rid of the absolute value signs by setting that expression that is inside those absolute value bars equal to the positive and negative value of C. So what we would do is we would set AX plus B equals C, AX plus B equals negative C. The reason why is because if you'll look at our notes right here at the beginning, negative 4 equals 4, or the square root, the absolute value of negative 4 is 4 and the absolute value of 4 is 4. So you have to set this equation equal to the positive and negative value of C. Okay? Then we will solve for the variable in both equations, and both X values will be our solution. Both X values will be our solution. So let's do a couple of them so I can show you. It's not near as difficult as what it sounds, okay? So let's go with example 1 here. We are going to take the absolute value of X minus 5 equals 9. All right. The absolute value is already isolated because it says isolate the absolute value expression. Well, it's already isolated because, look, if I cover up the right side of my equation right here, there isn't anything else except the absolute value expression. So we're going to leave it there. So the second step is we're going to rewrite the equation to get rid of the absolute value signs. We want to get rid of the absolute value bars. And we're going to do that by setting it equal to the positive and negative value of C. In this case is 9. Okay, so we have X minus 5 equals 9. And X minus 5 equals negative 9. So I set it equal to the positive and negative value of C. So now we're going to solve. How do we solve this? We add 5, X equals 14. And on this one, we add 5. What you do to one side, you must do to the other. Negative 9 plus 5 is actually negative 4. All right. Now I'm going to check this to show you. I'm not asking you to do this all the time, but I want you to fully understand what is taking place. So now let's check. All right. If I were to take the absolute value, now here, see I'm doing with pink and I'm going to use my pink. The X is 14. So I'm going to take the absolute value of 14 minus 5, and it says it's going to equal 9. Over here, now I'm dealing with purple, so it says X is negative 4, so I'm going to replace negative 4 with X. Negative 4 minus 5 equals 9. All right, so 14 minus 5, 9. Absolute value of 9 is 9, and 9 equals 9. So we're good. That's a true statement. Okay, so negative 4 minus 5. Well, we're going to simplify that to negative 9. So now we need the absolute value of negative 9, which is 9, which equals 9, which checks out also. So see, it's not near as bad as what you're thinking. Now let's do one where the absolute value is not isolated yet. Okay, so let's look at example 2. Negative 8 minus 2, absolute value bars of 5x minus 7 equals negative 14. Okay. Let me go back to our notes. Step 1 says, isolate the absolute value expression. So I have to isolate this before I can do anything. All right. So in this case, what I actually do is I pretend that my absolute value is like a variable, like it's an X. So I'm just going to use the top of the marker lid So I actually have, the way that I'm looking at it is negative 8 minus 2x equals negative 14. I am just looking because I want to isolate this, okay? So it says isolate, whoopsie, the absolute value expression. All right, so on a separate sheet of paper here, that's not on my notes. If you looked at this problem like this, negative 8 minus 2x equals negative 14. All right, we're going to pretend like this absolute value at this moment is just a variable so that I can isolate the variable by itself because we're used to isolating a variable by itself. So we're going to follow these steps. Well, what would I do? Well, the first thing I would do is I would add 8. I would have negative 2x equals, what's negative 14 plus 8? Negative 6. I would divide by negative 2. And x equals 3. That is something we're used to. It's familiar to us, right? So look, instead of having the x, I have an absolute value. But it's the same concept that we've been thinking about, that we still have to isolate my absolute value expression by itself, just the way we know how to isolate a variable by itself, okay? So we're going to use these exact same steps. So I have negative 8 minus 2. I see absolute value, 5x minus 7 equals negative 14. Now remember, you're thinking that absolute value is still a variable. So what was the first step we did here? Well, if we think the absolute value is a variable, we get rid of our 8 first. Well, that's what we're going to do. We're going to add 8. And what you do to one side, you must do to the other. So that cancels out. We are left with negative 2, absolute value of 5x minus 7, absolute value, equals negative 6. Sorry, that kind of looks like a box. It's not. Okay. Now what? Well, in this example, if we think that if we consider that x, or the absolute value, an x, a variable, we have to separate that negative 2 that's being multiplied by it. Okay, so we are going to now, we're going to divide by negative 2, divide by negative 2. That cancels out. And we have the absolute value of 5x minus 7 equals 3. All right? Now, some students say, but Ms. Yates, aren't we supposed to distribute? No, no, no. You only distribute when you have parentheses. This is actual absolute value bars. So the only way that you can get through these absolute value bars is if you have the positive and negative answer. All right? So now let's continue. Now I isolated, all in our rules, I isolated the absolute value expression. So now I'm going to rewrite it and set it equal to the positive and the negative value of C. Here we go. Oh, here, I'll leave that up there.